So the sharp-eyed amongst you will have noticed on the bottom of the welcome slide we have the Wi-Fi for the room, which is IRT public/BE20, and the password is here we go, all one word. If you want to tweet, I know Twitter is not necessarily a huge thing, but in this part of the world, but we'll try and look at comments that people make, maybe feed them back into the session throughout the course of the day. We've got a hashtag of ORPHEUS18. So our next speaker has been a powerhouse behind the project. Any great edifice needs an architect. Michael Weitnauer from the IRT is going to tell us about ORPHEUS's reference architecture. Michael.
Yeah, thank you very much, Simon. And good morning, everyone. It's really great to see so many people here interested in this topic, being at IRT. I'm very excited, to be honest. And yeah, now I'm having 20 minutes to bring you our reference architecture a little bit closer. It's actually a little bit of a pain. I mean, it's very technical, and I can even dive not very deep. I think that's a good thing, again, for you. But to be a bit more entertaining, I decided to use some analogies like roads, because it's not just a reference architecture that I'm introducing to you. I'm rather introducing the road ahead to the reference architecture. I mean, this road is, of course, perfect. It's straightforward. It's paved. It has marks. It has everything what a proper road needs. But you could imagine that our road was perhaps not as ideal as this road. I don't want to say it was perhaps like this one, but yeah, let's see. Please bear with me. I'm only the second presentation this morning, just to make sure that everyone is on the same page. What is object-based audio? Very brief, object-based audio is not immersive or 3D audio, or not just immersive or 3D audio. Object-based audio is rather audio along with metadata. So I think that's the very basic principle. This is then transmitted as individual elements. It's called an object-based audio scene along with the metadata to the end user, where the renderer is then using this audio signals and the metadata to process a signal that is perfectly suitable for the environment and for the loudspeaker setup at home. So this brings several advantages. So that means with just one production, with just one object-based production, you can offer very many possibilities for your users. So there is, of course, obviously the immersive aspect of your content. So you can very easily make 22.2, 5.1, whatever, immersive content out of your production. But of course, also legacy setups can be served with this production. But you can also make a binaural version, so for a headphone, easily out of that. You can offer profiles for your content. You can offer interactivity with your content. But of course, for me personally, the most important bit of this whole technology, the personalization of your content. So perhaps a slider that allows your user to adjust the volume of the commentary, of the dialogue within a certain range. And last but not least, of course, accessibility as another great feature of object-based audio. All these things can be done with the same production. This leads to some very basic questions. If you think about object-based audio in daily operation, first of all, will there be significant changes to our production workflow? Can all platforms be served? Are the production tools and formats suitable for broadcasters? Do we have an open, future-proof, and lossless format? Or which parts of the infrastructure need actually to be changed? And many, many more. So these are the questions that we try to address within the ORPHEUS project in the last 2.5 years. And our approach was, of course, not to reinvent the wheel. This doesn't make sense. So we decided, of course, to use existing and well-established workflows for our architecture. We decided to make an iterative process where we conducting several pilots, implementation of trials, and so on. And then we're using those lessons and the knowledge that we learned from those pilots and trials to design, develop, and format an interface agnostic reference architecture. Of course, only as far as this makes sense. This is no surprise. This is basic radio broadcast workflow. These are the stages that we identified and also used for the conventions within our project, from the recording to the reception and end-to-end workflow of radio production. So this is where we will learn, of course. This is very well known for you and boring stuff. So we started with our first pilot. We called it Stage A. And this was a complete live chain. And I think the most important bit here, from a technical perspective, is the usage of the BW64 file, which is able to carry the ADM metadata. So BW64 is the successor of the very famous broadcast wave file that you should know. And this is the successor and can carry all the needed object-based metadata. We used a complete live object-based enabled radio studio, which was, as already mentioned, the BBC IP studio, where we used legacy microphones as live sources, because this was a live radio drama, a live object-based radio drama. And for the distribution, we used legacy codec, because in web browsers, there is not yet an NGA codec available you could use. That's why we built on just AAC along with ADM within a dash container. So this worked out quite well. And on the reception side, there was a special web page using a JavaScript renderer. So all the rendering, object-based rendering, really happened within the end device in a normal custom, not custom, in a normal web browser. This is basically a user interface of this first stage of the Mermaid's Tears. This was the name of the production, and this is the basic concept of this production. So 3 perspectives, 3 actors speaking, where the user could change the perspective. I definitely don't want to go into more details, because there will be a talk later today introducing you a bit more, the details, and there's also a demo in the second floor. So then, next thing, Stage B. This was, we called it as live. The focus was mainly on pre-produced content. We used Sequoia for that reason, the object-based enabled Sequoia, but also legacy content. And this was also the first time where we used this concept of the pre-processing. So that means the reduction of the number of elements and also of the complexity of the object-based content in order to match the profile, the MPKH profile that we use within the project. This is low complexity level 3. And we just use more in the production, more objects, and to match those limitations that we had there, we used this pre-processing thing. So we used also MPKH software tools for the production here. And that's no surprise. Of course, MPKH distribution within a dash container again. And on the left-hand side, on the upper one, you see some screenshots of the app that we used for the reception of this content. We had produced several elements for this stage. And it was also the first time that we, I should say, introduced this new concept of a new step in the architecture. We called it presentation design, because object-based audio, as we learned, has some great opportunities to give additional information to the user. So not just the pure audio information, not just the pure audio signal, rather additional stuff like images or chapters, transcripts, and so on and so on. And just to emphasize that this is an important step that you don't have to use, of course, but that you can use to enrich the user experience. This is a new step in the architecture. So the next thing, stage C, again, a complete live end-to-end chain. We used pre-produced content as well as live sources. Live sources, again, in the radio studio using legacy microphones. But contrary to stage A, we didn't use completely IP infrastructure. We built on existing MUDI structure. And for that reason, to get the ADM metadata within MUDI, we used the so-called control track converter, which is just using an audio channel within the MUDI signal to transport the ADM or the object-based metadata. So this went via some BBC MUDI infrastructure, and then we again had MPEG-H encoding and reception for different devices. The iPhone again, and also the first time that we used the Trinnov AV receiver capable of decoding and rendering MPEG-H. The reason why I mentioned this control track converter is to emphasize that it's quite easy already to use your existing infrastructure. So you don't have to replace all your cables. You can use your existing cables to use object-based audio because, well, you just need one additional audio channel for that reason. The next thing, Pilot 2, is focusing on-demand mainly. The first pilot, or the first pilot stages, we're using, we're focusing on live aspects or live production and reception aspects of object-based audio, whereas the second pilot is focusing on the on-demand aspects. And we quite soon decided within our discussions in the project that we focus on one very specific aspect, one very specific feature of these on-demand possibilities, and this is the so-called variable length. Andreas already introduced the basic concept. That means what you see on the left-hand side here is a screenshot of the user interface where the user can change the duration of the program within a certain range. So if he has very little time, then he's going to what we call importance or level 1, and then he's going for a news item, for instance, only the headlines. If he has very much time and is very interested in the program, in the topic itself, then he's even expanding the default duration. He's getting all the information, all the detailed information additionally within his available time. From the technical concept, we used the EBU core scheme to tag certain parts of the program with different importance or levels, just to indicate those. These were then extracted in the distribution stage again, and along with the MPEG-H stream, multiplexed in a dash container again and transmitted to the end user. It was received with this user interface on the iPhone app, so the user could adjust the duration, and then with an additional request to the cloud, he got then those suitable bits of the program in order to have his personal duration. But we made, of course, also sure that this is working for what we call lean-back devices. So the user doesn't have to do this, and it works, of course, also with our AV receiver, who is just receiving the same MPEG-H stream, but without changing the duration. So it's just receiving the default duration of the program. So there we are. This was our road. It was certainly not as dangerous as this one. This is called the Death Road in Bolivia. It's said to be one of the most dangerous roads in the world. I think it's rather, straightforward, but a bit bumpy, I would say. So here we are. This is the ORPHEUS reference architecture. Of course, only a high-level overview. This figure you really don't want to see it if it would have all the details. I think it wouldn't even be possible. But I think it gives you a good idea of what we think is an appropriate architecture for object-based audio end-to-end workflow. And yeah, I'd like to emphasize now a few bits of this reference architecture. So first of all, we made sure that this architecture is capable of transporting both legacy content as well as object-based content. We used, and we also recommend, the usage of both legacy single source or single channel microphones, but also array microphones, because for certain applications it can be very beneficial for you to use such microphones in order to create your high-order ambisonic scene or create even objects out of your sound scene. We used, and we recommend very strongly, compliant renderers throughout your whole workflow. This is very important because, well, in the early days of object-based standardization, we had some debates because everyone developed his own renderer, and as you can imagine, it's sometimes difficult to make sure that they all sound similar or even identical. So that's why we really emphasize here the usage of compliant renderers for both the production and also the consumption in order to make sure that the user has the same experience as he should have. We are using different distribution formats because it is very likely that in the future you won't have to deal with just one NGA, as it's called, next generation audio codec or system like MPEG-H. It's rather likely that you have to use different ones because, let's say in the future you are using AC4 for your broadcast, for your DVB emission, but for the internet, for your on-demand platforms, you will be using MPEG-H because, well, that's the only available NGA codec for internet browsers. And then let's go one step further. Let's say you want to sell your program on a Blu-ray, then you perhaps have to go for DTSX or another flavor of those NGA codecs. And that's why it's really important to be independent within the production from those NGA codecs, but of course to have a proper interface. And the interface to all those NGA codecs is ADM. This is the audio definition model, and all those NGA codecs provide an interface to this format, which is great. What else? Already mentioned the presentation design, which is an additional and new step in the workflow, just to emphasize that you should do it, you could do it, but you don't have to do it. So you can always use the same user interface for your programs, but you can, of course, make nice images, nice whatever, all the additional stuff for your user to enrich his experience of your content. Of course, if you now make a transition or a switch to object-based audio infrastructure, you shouldn't forget all the legacy devices that are available, all the millions that you have to serve, and that's why you should definitely integrate a renderer already in the distribution stage in order to produce automatically different versions out of your content suitable for your existing infrastructure like DAB or DVB or other things. We also recommend new things like metadata enhanced microphones. So microphones used in the studio, for example, that already carry additional metadata and information which are useful for object-based audio productions. And of course, our reference actor is covering all the different end devices that are nowadays usually used, from mobile to computers, desktop computers to AV receivers. Those three different ones can all be served with our reference architecture. Okay, now again a very quick summary of our used formats and standards. In the production, which is basically the ITUR and EBU world, we used BW64 as a file format. We used for the object-based metadata ADM or the serialized ADM, which is the streaming version of ADM and will be hopefully published as another ITU publication within the next months. We use for additional metadata the EBU core scheme, like for the indication of the different importance levels of the program for the variable length. And a very important bit, we used a new publicly available open source renderer, the EBU ADM renderer, which is also now available since a few weeks now. For the distribution, we've chosen, obviously, MPGH as an NGA codec, but we also used ASC along with ADM to serve web browsers with the object-based content, and all those streams were served via a Dash streaming container. What we didn't use, what I think is worth mentioning here again, for the broadcast emissions, so like for the traditional stuff from DVB and ATSC, there are already new versions published which are covering those new NGA codecs. So your new TV device that you can buy nowadays, or perhaps, let's say in a few months, which is capable of UHD, HDR, and all these nice things, is very likely also capable of decoding and receiving AC4 or MPEG-H. So even in this market, it's very likely that you can have these great opportunities. Still 5 minutes, wow. Already using. This was perhaps now a little bit much, again, in terms of standards, documents, and so on and so on. And that's why I'm really highly recommending reading this document. This is EBU Technical Report 42, mind the number. And it is, I think, nice 25 pages around document carrying all the detailed information about our reference architecture. Much more than I could cover within this 20 minutes slot. This QR code leads you to an URL where you can see directly a PDF version from this document. I found another one. I just liked it. It's not mine, but it's somehow reflecting my feeling after these 2.5 years now. I think we did a great work in the last 2.5 years, and I hope that you will agree with me, perhaps after this day only, that we did a good job, and we also did the necessary work in order to ease your transition to an object-based audio infrastructure. And I found this quite suitable. And this brings me already to the end of my presentation. Yeah, thank you very much.
Michael, thank you very much. I think one of the things we're going to find during the day that as this is an EU-funded project, it's generated quite a lot of documentation, so there's going to be plenty for people to pick up on later. I see from, radio and broadcasting in general, but radio in particular, traditionally has been a very linear experience. And radio particularly, it's kind of 80% live. But you picked up in the architecture about the possibilities for non-linear. Do you just want to highlight, because I think Mathis on Twitter raised this question, it's a really interesting one, how the ORPHEUS architecture supports both technically but also creatively, aesthetically, a non-linear way of working.
Mm-hmm. Okay. I should go back to This one, perhaps. I should say the architecture that you need for on-demand or for all these features is actually not very different. You only leave out the radio studio. You go for only the pre-produced stuff, and yeah, that's basically it. It doesn't, from a technical point of view, it doesn't make a very big difference for our architecture, whether it is a live stream or whether it is going to be on-demand reception. I think that's basically the answer to your question.
And I guess the other thing that, for most people who work in radio today, the importance of metadata, describing all of those components and allowing you to navigate and reassemble them, becomes even more crucial. So in terms of the way we work and the way that the systems generate information, that's now a really critical part of the underlying structure. Do we have any other questions in the room? Fantastic. I need some exercise.
Thank you. Jan Fleischmann, Platzer Media. As we have a discussion going on here with digital audio broadcasting and versus streaming, maybe you left out digital audio broadcasting and showed digital DVB or ATSC 3.0. So is it compliant with DAB+? Would it be also possible to put in this object-based NGA audio files or whatever thing?
Okay, so as far as I am aware of, and I must say I'm not an expert for DAB, but as far as I know, you currently cannot transport an NGA codec within DAB, just plug and play. I think from a technical point of view, this would be possible, but the standard itself had to be updated, and the devices would need the necessary multiplexer, demultiplexer, encoder, decoder, of course. But I think from a technical point of view, this would be possible. That's why we used in our reference architecture the DAB or DVB, but not for the transmission of object-based audio itself, but rather for a already rendered version of your object-based program, which is then fitting the stereo or 5.1 setup.
Thank you, Michael. One last quick question, anybody?
I'm Lars Hed from Swedish Radio. Going back to the time-stretched production again, did the journalist have to write the scripts in a different way to make it work as intended?
Good question. As far as I heard from my colleagues, they actually did not have to do things differently. So we started with, I think this is already published in the app, the experience object-based audio is capable of the variable length feature, and we produced this actually not having in mind this variable length feature. We just did it for the linear consumption of this content. But afterwards, we found out, hey, well, we can just use it. It's very easy. We just have to indicate the right parts of the program with the right level. And well, it worked. We also, as a second trial, I think this is not yet published, we used 1 hour of news program from the BR, from B5. And we just recorded it and again indicated the different parts in the program with different levels. And this worked out quite well because it seems, as I understood, that the content, the program, as they are produced and written by journalists already today, are following somehow this approach. So starting with the most important one and then going always a bit deeper with information.
Thank you, Michael. One last question. Go on then, Florian.
Florian Camera, Austin Television. Did you also discuss of who is going to tag the importance of the individual elements? Because I think in a news environment, it could be a political issue.
Yeah, good point. We didn't Yeah, we didn't discuss too many political things within the project. As you can imagine, it's a technical project. But yeah, as I learned within the project, many of those news items, for example, are produced, technically produced, or also by the journalist, so not by a sound engineer. So it would be already the right person to do this, this tagging. If it's a different person, then yeah, of course, this needs then someone who is really responsible to do this.
Michael, thank you very much. And obviously, the demonstrations that we'll all get to very shortly, there's an opportunity to look at some of these non-linear workflows in a bit more detail and find out how they've been used creatively.